Clark, go ahead.
Thank you, Karen. Today we'll be going through the A9000 and A9000R zoning and cabling guidance from GTS, April 2017 edition. You'll note in this presentation that not all possible configurations are covered. And it's somewhat intentional as we've tried to cover only approved configurations and configurations we think will be common exceptions. So it's not an exhaustive list. If you have questions on cabling guidance for your configuration that is not answered here, you can always request additional assistance. On slide 2, I'll take a quick overview of the A9000R and its specific specifications. The R denotes a rack-based deployment. It has 2 or more grid elements. You can see it on the right of the slide with all 6 grid elements enabled. In the middle is a switch and passive backplane. You'll see that in all configurations with either 2 or 6. It doesn't matter. That's always there. Each of the elements consists of 2 grid controllers and 1 flash enclosure. Configurations are outlined on the slide. Pretty straightforward. You can see that there is an InfiniBand card in there, dual port, 56 gigabit, full data rate, 16 lanes, 2 compression accelerators, and 2 or 3 dual ported host adapters. The standard config is 2 fiber channel cards and 1 10 gig E. The flash enclosure, GTS standardized on the 5.7 terabyte cards, gives us 57 terabytes usable with RAID overhead. So basically, you're losing 2 of the 12 possible cards due to the RAID overhead. So those aren't usable for assigning space, but just to point out that they are spare capacity. It doesn't actually set aside 2 cards as spares. I know that question had come up in some of the early account usages. Also denoted by the blue background is the standard GTS half-rack configuration. That would be equivalent to the Model 300. Right. You'll note later in the slides that GTS does rate it as slightly less space than you'll see in the Systems Group marketing, and I'll talk about the reasons for that as we proceed. On slide 3, I'm going to take a closer look at the A9000R grid controller ports. So on the top is the standard mixed configuration, fiber channel and iSCSI configuration. Please note that the 10 gigabit Ethernet and the fiber channel ports are using QSFPs, so they will look very similar. Don't mix them up. You won't be able to tell that you've plugged it into the wrong card. It just will not function. So pay special attention to this on the slide. As for the 4 FC ports, 2 are meant for SAN connectivity and 2 are meant for migration and replication functions. You can use those for standard SAN connectivity if you have no plans on migration or replication, meaning that you would only ever have 1 unit in your environment or not have any desire to move data in or out of it. However, we highly recommend that you stick to the standard 2 and 2 setup. On the bottom right is the alternative iSCSI only configuration. Same rules here apply to the iSCSI config. 2 of those are meant for SAN connectivity and 2 are meant for migration and replication functions. On the next slide, slide 4, is the A9000 pod configuration. This is not currently the GTS standard. There's a potential that may change later in the year as the configuration hardware is slightly updated. This is basically 1 grid element, and you can see it on the slide there with the rack elevation beside it. It takes 8U or 8 rack units in total, so there's no switch here. It's just 3 grid controllers and 1 flash enclosure. You can get smaller configurations with the pod, notably the 1.2 terabyte cards, but again, GTS standardizes on the 5.7, and it's got the same RAID overhead as the A9000R version. Notable here is the current configuration is 192 gigabytes of RAM, which serves as your cache. Put it close to performance parity with the A9000R. On the next slide, slide 5, we're going to take a slightly closer look at the A9000 grid controller ports overview for the pod configuration. So these are very similar to the A9000R configurations. If you look really close, you will be hard-pressed to discern what is the difference. You'll have to go back and forth between the slides a few times. It's the InfiniBand cards. Layout's slightly different. Same rules as before and same wording as before. The 10 gig E ports and the SC ports look very, very similar. In fact, they fit the same type and size transceivers or SFPs. So you can easily plug the wrong one into the wrong card and it will just not function. There's not really any warning giving for that. Bottom right is, again, the iSCSI config, just like on the previous slides. Same rules as before, just showing you the hardware layout. On slide 6 are the general instructions for the fiber channel storage connections. So you'll note that the picture on the slide actually labels the fiber channel ports and the iSCSI ports for you with port numbers. That's to make it easy so that you can play in your physical cabling. That is the A9000R that is shown there. So ports 1 and 2 are on the same fiber channel card, and ports 3 and 4 are on the same fiber channel card as shown in the picture. So you use ports 1 and 3 for the standard storage connectivity. That way you have one port on each card. Port 1 is for fabric A and port 3 is for fabric B. Ports 2 and 4 for any replication or migration connectivity. Now, we've done something a little bit different here. Odd grid controllers go on fabric A, even grid controllers go on fabric B. So yes, we are splitting those by the grid controller and the grid controller number, not the card or fabric or port. The reason that we're doing that is that for replication, those ports have to be able to talk to each other. So we're splitting it on the grid controllers because of that instead of on the ports or the cards. Just a note here, you should have seen this on the previous slide, but grid controllers are numbered from the bottom up. On slide 7, we have the storage cabling layout for the A9000R. This is the GTS standard, meaning that this is the current preferred hardware option over the pod. Right now there is a performance disparity between the rack version and the pod version. So that's one of the primary reasons that we have standardized on the A9000R for the moment. Here you can see 2 different layouts. They are labeled 4 grid controllers and 6 grid controllers. That equates to 2 and 3 element layouts. Those are the approved standards for the rack config. The 3 element is the half rack config that was shown earlier in the presentation. That's our preferred config. We have a smaller version of 2 element or 4 grid controller config as shown here. So the way this is done is the host connectivity, i.e. the standard storage connectivity, is shown on the left-hand side boxes with the module and port that goes to each fabric. So M1P1 equates to module 1, port 1. On the right box, you'll see the replication connectivity. So if you currently have no replication or migration connectivity needed, then you don't need to worry about the box on the right-hand side. So that's the same layout for both of these, the 4 grid and the 6 grid controllers. Both have standard connectivity on the left and the the replication connectivity on the right. Again, if your configuration deviates from standard, please ask, but these should be fairly straightforward. And these are meant to show the storage cabling layouts, so these are physical cabling. Slide 8 is for the pod. It's not the GTS standard, but we've listed it here just so that we have a consistent reference, because we have encountered some of these in the field already. It's very tempting for a lot of clients with smaller storage requirements. So we show here the standard storage connectivity and the replication connectivity on the right, just like it was on the previous slides. Note here that the replication connectivity on the B fabric is not balanced. Well, that's because of our rule way back on one of the earlier slides that said even and odd go to certain fabrics, right? So we've got modules 1 and 3 on the fabric A, just as we specified in our rule, and module 2 on fabric B. We realize that's not balanced. Unfortunately, with a 3-controller config in the pod, it is impossible to balance the replication connectivity because the 2 ports on the same module have to be able to talk to each other. There's no way around this. All right, next slide, slide 9. This is instructions for the iSCSI storage connections. Currently, I would advise that you look at our reference materials for iSCSI, but we'll have specific guidance appear in the next release with regard to the A9000 family of products. Slide 10. So this is just a little intro to the zoning that we need to think about with the A9000 product family. So this is a logical view that we're going to talk about here. It's not going to be explicit. The goal here is to provide you guidelines that you can use for standard configs, and hopefully everything you do is a standard config. Otherwise, you need an exception approval from Jim Olson. You can reach Jim from his jimolson/southbury/IBM email in Lotus Notes. On the next slide, slide 11, is zoning for a 2-grid element A9000R with 2 ports on the server. So you need to zone 4 storage ports for each server side port allocated. And this is shown on the diagram in the right-hand corner, along with the fabric that they're supposed to be on. The modules and ports are listed. All right. Notice here that this is just the standard connectivity, not the replication connectivity. So this is a balanced set of connections. So we've got 2 HBAs with 2 ports each. We're using only 1 port on each HBA in this diagram. That is intentional, right? We're not harming ourselves with that. It's just limiting the number of paths. Anything more than 8 paths typically provides some sort of performance impact on the server side due to the multipathing selection algorithms. It's not always. That's just most of the time with most of the multipathing software, so we try to stick to 8 ports or less, 8 paths or less. Slide 12. 2-grid element A9000R with 4 ports on the server. So again, the diagram on the lower right-hand side provides you a logical layout and shows you how you're supposed to configure these from a zoning level. Again, 8 paths are provided. Slide 13, zoning for the 2-grid element A9000R with 6 ports on the server. So this one's a little more complicated. Here we've chosen to leave out the 3rd adapter, or the 5th and 6th if you're using single port adapters, because it greatly simplifies the configuration here and makes it look like the configuration on the previous slide. So it's very straightforward. Again, 8 paths are provided on the server side. Next slide, slide 14, zoning for a 2-grid element A9000R with 8 ports on the server. So here we're doing a 1-to-1. Right, so one port on the server side to 1 port on the storage side. We've got to split out between fabric A and B, and hopefully the diagram makes it very simple from a logical standpoint to see what you need. Again, this isn't meant to provide explicit zoning guidance. It's just to show you what you need to zone together and have visibility between, to assume that you understand how to do the zoning on whatever product you're using. Again, this will provide 8 paths on the server side. Slide 15, we begin with the 3-grid element A9000R configurations. So first one is a look with a server with 2 ports. So here we have the storage ports split into 3s between the fabrics. This will provide 6 paths on the server side, and note that you are leaving 6 ports for future use. Okay? You can round robin those, or you can use the next 2 ports on the next host. If you want to do that, really it's up to you. It's just on how much tracking work you wish to do. All right, slide 16. 3-grid elements with 4 ports on the server. So as shown in the diagram here, note that if you do not follow the zoning host definitions introduced on this slide that we haven't had on any of the previous slides, you'll end up with 12 paths on the server side. Okay, that is likely to provide some sort of performance loss on the server side because that's just too many paths. So in order to reduce that, what we're going to do here is define 2 host definitions as shown on the storage side. We're only going to assign each volume or LUN to 1 of the host definitions. Okay, that will give you 6 paths on the server side if you do that correctly. So what we're talking about here is the first host definition has HBA1 port 1 and HBA2 port 2. The second definition has HBA2 port 1 and HBA1 port 2. Again, this assumes you're using 2-port HBAs, as those are fairly common. This gives you connectivity on each side of the fabric and no loss in redundancy, while maintaining a lower number of paths for optimum performance. Slide 17 is zoning for the 3-grid element A9000R with 6 ports on the server side. So again, the diagram here hopefully makes this very straightforward. The change here is that we're using 3 host definitions instead of 2. That's done so we can balance the port assignments between the fabric. Right? So every host definition has a port in one fabric, and it also reduces the number of paths that you see on the server side. This will reduce it down to 4 paths on the server if you do this correctly. If you don't, you'll end up with 12 paths. Slide 18, zoning for 3-grid element A9000R with 8 ports on the server. So here, we again assume that you're using dual-port HBAs, as this seems to be the most common configuration. We're actually going to leave the 4th HBA unused. We do this to simplify the zoning configuration and ensure that everything is easy to balance. We're going to again define 3 host definitions like we did previously. Again, this will give us 4 paths if you do it correctly. If not, we're going to end up with 12. All right, on slide 19, the A9000 pod attached to 2 ports on a server. So again, diagram on the lower right-hand side. Hopefully fairly straightforward. Please note that this does not show any replication ports, right, because we're only covering the standard storage connectivity. This provides you 6 paths on the server side, assuming you do it as the diagram depicts. Slide 20 is the A9000 pod again with 4 ports on the server. So this one is a little complicated because the pod has 3 flash controllers. So instead of leaving a controller out, here what we're doing is we're doing a little bit of round robin between the server ports, so it's not completely balanced because it can't be. There were several ways to do this, and ultimately we elected to make this the standardized approach because it was the most straightforward. All right, this provides 6 paths on the server side if implemented as shown. Slide 21. This is zoning for the A9000 pod attached to 6 ports on the server side. So zone 1 storage port for each server side port. This is essentially a one-to-one because it's single initiator, single target, and 6 paths on the server side. This makes it very straightforward, much simpler than the previous slide with 4 ports. Slide 22 is the A9000 pod, again attached to 8 ports on the server. So zone 1 storage port for each server side port. We've left out, and did not show it on the diagram, but we've left out HBA number 4. Right? We've done that again to simplify the zoning and cabling. Really, anything beyond 2 HBAs, you're unlikely to be able to push with a single system. So there is little, if any, performance impact by dropping out that 4th HBA. And that provides 6 paths on the server side. All right, change pace a little bit. We're going to look at slide 23 for some server-side guidance. This is all high-level stuff, just to level set you on what you can and cannot do on the server side to affect performance. So the maximum port queue depth for the A9000R and A9000 is 1,400 for each port. That means that roughly each port is capable of 140,000 IOs on the storage. Okay? So each storage side port equals 140,000 IOs. That's your rule of thumb. Okay, that's not an absolute. That's just a planning number. The second thing you need to know is the maximum host side queue depth is for the A9000R and A9000 is 256 for each WWPN. That means that rule of thumb is 25,600 IOs for each WWPN on the host side. Okay. Here is a very handy rule of thumb for queue depth planning. It's 0.01 seconds per IO, that's 10 milliseconds. Is that a realistic number with all storage devices? Absolutely not. Okay, but it's an easy number for someone to use to plan with. It's always better to be conservative when you do planning, and 10's a nice number. Right, makes it very simple. So here we show how this works with a sample queue depth of 32. So if I take 32 and I divide it by 0.01 seconds, that gives me my maximum of 3,200 IOPs. Right? That's a very easy way for you to plan queue depth from the server side. In general, you should find that bare metal systems typically will not need any queue depth tuning, while the virtualized systems will usually need some, unless they're just not very busy. If you need more guidance than this, we highly suggest that you take a look at the linked Red Book, particularly the performance and tuning chapter in that Red Book. Slide 24 are some gotchas to watch out for. So servers that are clustered together, particularly ESX, Oracle Rack, and the like, should be zoned to the same A9000 target ports. That removes the possibility of any type of I/O delay or path instability due to path inconsistencies on the clustered servers. So what we're really saying there is, if you're using a cluster of any type, remember that the storage environment has to look the same to all the systems that participate in that cluster. If they don't, you're going to run the risk of performance or instability due to those differences. Slide 25, in closing, is frequently asked questions. This will expand over time, but right now we only have 2. So question number 1 is, why don't you allow for more paths per server? I hinted at this throughout the slides, but 8 is the optimal number. Right? That's the optimal number across most of the operating systems that we support. Beyond 8, most multipathing begins to degrade performance. Why? Well, the path selection algorithm is really tuned for 8 or less. And that's fairly common. Not all vendors multipathing will behave that way, but 9 out of 10 will. This came up. Why are the replication paths imbalanced on the pod configuration? I talked a little bit about this on the slide, but just a reminder, this is because the ports need to communicate with each other for the replication migration function. Hence, we have balanced the replication ports based on the module number and not the card or port number. That means that with the pod configuration that you end up with an imbalance on the replication ports because there are only 3 modules or grid controllers in the configuration. So the Fabric B is going to end up a little light. There's no way around that because there's only 3 controllers. So one of the fabrics is going to end up with a lesser number of ports. In the grand scheme of things, that really should not impact your performance very much. I thank you for your time today and listening to this guidance. As always, feedback is appreciated. Thank you and have a great day.